Let's solve some additional problems. Okay, now we are going to use the dr concept to show that the points a, which is 5 11 minus 6, b, which is 3 5 3 and 5 3 5 and minus 2, and c, which is 2 2 0, are collinear. That means they lie on the same line. Now let's see how to do that. Dr of AB would be what? Would be 3 minus 5, 5 minus 11, and minus 2 minus minus 6, which is plus 6. So which is equal to minus 2 minus 6 and 4. Okay, similarly drs of BC would be BC. So 2 minus 3 is minus 1, 2 minus 5 is minus 3, and 0 minus minus 2 is plus 2, right? And if you multiply this by 2, you get the drs of AB. That means drs of AB and BC are proportional. So therefore AB and BC are parallel, but B is common, which implies that AB and BC are collinear. Okay, let's do the second one. Now we have to find the angle between the diagonals of a cube. So let's draw a cube first so that we get an idea. So let's draw a cube behind. This is the back side. Let's say this is the coordinate axis. This is x, this is y, and this is z. Okay, let's say this is A, this is B, this is C. Okay, this is O for origin. Let's say this is P, this is Q, this is R, and this is S. Okay, now let's figure out the coordinates of each of these axes, vertices. Okay, so OA, remember it is a cube, so which means all the edges are of same length. So OA is equal to OB is equal to OC, and let's say that is A. Okay, now the coordinates of each of the vertices would be let's say O is equal to 0 comma 0 comma 0. B, no, let's start with A. A is equal to A comma 0 comma 0. B is equal to A comma 0, no, 0 comma A comma 0. Okay, now what about C? C is 0 comma 0 comma A, because they are lying on the axis itself. Okay, now let's look at P. P is A comma A comma 0. Q is A comma A comma A. R is equal to A comma 0 comma A. S is equal to 0 comma A comma A. So A, B, C, okay, A, B, C, O. And then we have P, Q, R, S. Okay, so we have written all the. Okay, now what about the diagonals? Diagonals are OQ. Look at the diagram. O to Q is one diagonal, A to S is another diagonal, B, R is diagonal, and PC or CP is diagonal. So OQ, AS, P, what is that? PC and VR are the diagonals. Now the direction ratios of OQ is equal to what? OQ. This would be A minus 0, A minus 0, A minus 0. So that means A. Now AS would be direction ratio would be A is this, S is this. So minus A. Direction ratio of PC is P and C is 0 minus A. So minus A plus A. And finally BR would be A minus A plus A. Okay, I don't have to write this plus, I can just leave it as A. So we have got the direction ratios. So now let's figure out the angle, let's say theta 1 between OQ and AS. So cos theta 1 is equal to, we know the formula, just apply that, A times A minus A plus A times A plus A times A divided by square root of A square plus A square plus A square times A square, actually minus A square plus A square plus A square. This becomes minus A square plus A square plus A square divided by these two square roots will cancel out each other because these are square roots of the same this one. So this will become A square plus A square, 3A square. Let me write it, square root of 3A square, which is equal to, these two get cancelled out, A square by 3A square. So A square cancels, 1 by 3. Okay. So this is cos theta 1 is equal to 1 by 3. Now let's look at angle between, let's say theta 2, between PC and VR. So again cos theta 2 is equal to minus A square plus A square, minus into minus, plus A square plus A square divided by square root of, again here, because we have squares, they all will, minus signs will disappear. But for completeness sake, I'll just write it, times, and here you have A minus A. So A square plus minus A square plus A square. So this is equal to, these two get cancelled out, A square by A square, that is 3A square times 3A square, which is equal to A square by 3A square, which is equal to 1 by 3, right? So now if you notice, cos theta 1 is equal to cos theta 2 is equal to 1 by 3. So which implies theta 1 is equal to theta 2 is equal to cos inverse of 1 by 3, right? So that is the angle between the diagonals of a cube. Let's look at the next one. Now let's say we have the same cube. So a line makes angles alpha, beta, gamma and delta with the four diagonals of a cube. Yes. Now what we have to do is we have to show that 1 cos square alpha plus cos square beta plus cos square gamma plus cos square delta is equal to 4 by 3, and we also have to show that summation of sine square alpha, this is a short form of writing sine square alpha plus sine square beta plus sine square gamma plus sine square delta is equal to 8 by 3. Okay, so first let's figure out this cos alphas. So once we know cos alpha, cos beta, cos gamma and delta, then it's just a question of substituting, right? So now let me just very briefly draw this. Yes, okay, this is A, B, C, O, P, Q, R, S. Okay, now let's write the coordinates of all this. So let's say OA is equal to OB plus O is equal to OC is equal to A. So now O is equal to 0, comma 0, comma 0. A is equal to A, comma 0, comma 0. B is equal to A, no, not A, 0, comma A, comma 0. C is equal to 0, comma 0, comma A. Now P is equal to A, comma A, comma 0. Q is equal to A, comma A, comma A. R is equal to A, comma 0, comma A. And S is equal to 0, comma A, comma A. Now the diagonals are what? Diagonals are OQ, AS, BR and CP. DRs of OQ is A, comma A, comma A. O and Q. A minus 0, A minus 0, A minus 0. So DRs of AS would be minus A, A, A. Of BR is A minus A, A. And CP is A minus A. Right? Now let's figure out the direction cosines. Direction cosines of OQ. This would be A by square root of 3A square. Now from where did this 3A square come? A divided by square root of A square plus A square plus A square. Similarly, A by, actually what will happen is this A square will come out, A will get cancelled out. Yes. So which means we will end up with 1 by root 3, 1 by root 3 and 1 by root 3. In this case 1 by root 3, 1 by root 3, 1 by root 3. In this case 1 by root 3 minus 1 by root 3 and 1 by root 3. Here 1 by root 3, 1 by root 3 and minus 1 by root. So we have got the direction ratios and direction cosines of the diagonals. Now let's focus on the line that is crossing these diagonals. So let L, M and N be the direction cosines of the given line, making the angles alpha, beta, gamma and delta with the diagonals. So cos alpha, we know angle between two lines. Cos alpha is equal to what? 1 by root 3 times L. So 1 by root 3 is the direction cosine of the diagonal. L is the direction cosine of the line, plus 1 by root 3 m plus 1 by root 3 n. Or what we can do is we can write it as 1 by root 3 is common, so we can take it out and write it as L plus m plus n. So now based on this pattern we can write it very quickly. Cos beta is equal to 1 by root 3 times minus L plus m plus n depending on the sign. See, okay. Cos gamma is equal to 1 by root 3 L minus m plus n. And cos delta is equal to 1 by root 3 times L minus m plus m minus n. Okay, now we have got everything in place. Now what we have to do is show now we can take up individually the equalities that we had to prove. So the first one was cos square alpha plus cos square beta plus cos square gamma plus cos square delta is equal to 4 by 3. This is what we had to show. Now let's take the LHS. Cos square alpha is what? 1 by root 3 is there for all of them, and it will get squared. So which means 1 by 3. We can take it out. Then we take up each one of these. So L plus M plus N square plus minus L plus M plus N square plus L minus M plus N square plus L plus M minus N square, right? Okay, so now let's simplify this. 1 by 3 n square plus m square plus n square plus 2lm plus 2ln plus 2mn. Okay, l square plus m square plus n square. Here I have to put a plus. Now L has a minus, so wherever L appears we have to put a minus. So minus 2Lm minus 2Ln plus 2Mn plus, now M has a minus sign. So L square plus M square plus N square minus 2Lm. Here L was there, here L was there, here M is there. Here M is not there, so plus 2Ln. Here M is there, so plus, no, minus 2Mn plus, now N is minus in the last one. So L square plus N square plus N square plus 2Lm minus 2Ln minus 2Mn. Looks very complicated. Let's see whether we can do any cancellations. Plus 2Lm minus 2Lm minus 2Lm plus 2Lm, 2Ln minus 2Ln, 2Ln minus 2Ln, 2Mn minus 2Mn, 2Mn minus 2Mn. So what we are left with is 1 by 3, and if you notice L square, M square, N square appears 4 times. So we can directly say 4 by 3 L square plus M square plus N square. And we know what that is. This is nothing but 1. So 4 by 3, which is equal to the RHS. Okay. Now what was the second one that we had to show? We had to show that sine square alpha plus sine square beta plus sine square gamma plus sine square delta is equal to 8 by 3. Now we already have it in cos form, right? So let's convert this into cos form. What do we get? 1 minus cos square alpha plus 1 minus cos square beta plus 1 minus sine cos square gamma plus 1 minus sine square delta. No, not sine square, cos square delta. This is our LHS. So this would be what? 1, 2, 3, 4. So 4 minus is common. Let's take it out. Cos square alpha plus cos square beta plus cos square gamma plus cos square delta. And we know what this is. This is 4 by 3, which is equal to 12 minus 4 by 3, which is 8 by 3, which is the RHS. Okay. So that is some additional problems with respect to the angle between two lines. That's it for now. Bye.